Hi. In today's class, we will go through acidic character of alcohols and water. We will compare the acidic character of alcohol and water. Then we will see which one is more acidic than the other and the reason why it's more acidic. Right? So whenever we talk about acidic character of any compound, right, what we mean is by saying acidic character that a compound can lose up a proton, right? It can lose a proton, that gives it an acidic character, right? The more easily that compound loses a proton, right, the more acidic it is, right? So any factor that affects the loss of proton will affect the acidity, right? If due to something the loss of proton will become difficult, then that will decreases the acidic character, right? So on these lines we will compare the acidity of alcohols and water, right? So alcohols are acidic. We have done the structure of alcohols, and if you just recall, you'll get to know why alcohols are acidic. If you just look at this, we have done this while doing the structure of alcohols as well, right? This is ROH, alcohol, right? And oxygen atom in this OH bond, when we say this alcohol is acidic, it means it will lose this proton, right? That is why it is acidic. Now let's see how easily it can lose proton. Since this oxygen atom is electronegative, this is electronegative, right? So what it will do is, since it is electronegative and this OH bond, right, OH bond has a bond pair between, right? Now what it will do is, it will attract this bond pair of electron towards itself, right? Now this bond pair of electron would be more towards oxygen. Why? Because oxygen is more electronegative, right? And it is this bond pair in OH bond that holds these two atoms together, right, in OH bond. Now when this bond pair will move more towards oxygen, now this bond pair has, because it is away from hydrogen now, so it has less control on hydrogen, right? So now since it has less control on hydrogen, this hydrogen can be easily lost by a proton. By a base, right? So if you have a base, this hydrogen would easily be removed, right, or abstracted by a base to give you this, right? Similarly here, if you have a base, what it will do is, since this this hydrogen atom can be easily abstracted, right? Why? Because of high electronegativity of oxygen atom, right? This bond pair is more towards oxygen and less towards hydrogen. It is away from hydrogen, so it has less control on hydrogen, right? So since it has less control on hydrogen, this hydrogen can be easily removed, right? Now since this hydrogen can be easily removed, this shows that it is acidic. Alcohol is acidic, right? So basically this alcohol is acidic because of high electronegativity of oxygen atom, right? So let me type it over here. Alcohol is acidic due to high electronegativity of oxygen atom, right? That makes OH bond weak, and hydrogen can be easily lost or abstracted by a base, right? I hope this is clear. Now we know why our alcohols are acidic, right? But this acidity of alcohols is very weak, right? It is weaker than even water, right? So we say that alcohols are weaker acids than even water, right? Now let's see what makes what makes alcohols less acidic than water, right? Again, we need to look at the structure of alcohol, right? If suppose this is an alcohol, right? Suppose this is an alcohol. We know that in alcohol, here we are looking at now, alcohols are weaker acids than water, right? Why? Right? Since in alcohols, this R group is electron donating, right? This R group donate electron towards this carbon atom, right? Which will again donate electron towards oxygen atom, right? So this, when we say electron donating, if this alkyl group is donating electron, this is your, we call it as inductive effect, plus I inductive effect, right? So your R group has plus I inductive effect, plus I effect, right? Due to which it will release electron towards carbon atom, right? When it will release electron towards carbon atom, so you have more negative charge on this carbon atom. So it is releasing actually electron towards this oxygen atom also. Now if this oxygen atom has more negative charge, since if it has more negative charge due to electron donating nature of R, this OH bond will become stronger bond, right? Now if this OH bond is stronger bond, then the removal of hydrogen will become difficult, right? So if your R is electron donating, right, now your oxygen will become negative because it is releasing electron towards carbon atom in this direction, right? Now if your oxygen is more negative, then you know we have a bond pair, that electron, we have a bond pair between O and H, between OH bond, sorry, between oxygen and hydrogen we have a bond pair, right? It is due to this bond pair that we have a bond, these two are joined together, oxygen and hydrogen. Now if you remember here, this bond pair of electron, right, due to this negative charge on oxygen atom, due to plus I effect of alkyl group, right, so this bond pair will be repelled away from oxygen atom, right? Now we will be comparing it with water. Since this bond pair will repel towards hydrogen atom, right? So now this bond pair has more control on this hydrogen atom. That will make the release of hydrogen atom difficult. Or what we say that this OH bond is strong bond due to plus I effect of R group, alkyl group, right? Plus I effect of alkyl group will increase the electron density in OH bond, right? This electron bond pair will move more towards hydrogen atom, so it will make this OH bond a strong bond, and that will make the release of this hydrogen atom difficult, right? And if you look at this water, in water you have two hydrogen atoms, right? None of them has ability to release electron towards this oxygen atom, right? Let's draw it this way, not this way. This is your hydrogen, this is your hydrogen, right? This hydrogen and this hydrogen, no plus I effect, right? No electron releasing effect that can make any one of the bond stronger bond, right? So this proton can be easily lost in comparison to alcohol, because alcohol has, because actually the acidity is because this water can lose one proton from this OH bond to form hydroxide plus hydrogen ions. Right, now if you look at the same thing in your ROH plus proton, but this release of proton from this alcohol is difficult compared to release of proton from hydrogen atom. Why? Because of plus I effect of alkyl group, this alkyl group, which will release electron towards oxygen atom, right, and it will shift this bond pair towards hydrogen atom, or what we say is that this OH bond will become a strong bond due to plus I effect of R group, and there is no such plus I effect in case of water. So water is a stronger acid because there is no plus I effect of in water, so this proton can be easily lost. The more easily proton can be lost, the more stronger is the acid. So that is why water is a stronger acid compared to alcohols, right? I hope this is clear. Now we'll look at one more thing. If we talk about our CH2OH, this what R is doing, it will release electron towards carbon, towards this OH bond. When it will release electron towards this carbon or in this direction, it will strengthen this bond. It will make this bond a strong bond. That will make the release of proton difficult. Now if we talk about CH, this is your 2 degree alcohol. Right? Now we have two R groups. Now both these R groups show plus I effect. That is, both these R groups will release electron towards carbon atom, it will release electron in this direction. Right? Now more alkyl groups means more electron release, more electron density on oxygen atom. Right? On this oxygen, because electrons are being released in this direction. So now compared to this OH bond is more stronger because you have two alkyl groups showing plus I effect. Right? Now if we talk about this, this is even more stronger. This is even more stronger compared to this. Why? Because now we have three alkyl groups, right, that can release electron towards the OH and will make OH bond more stronger bond, right? So if you compare the acidity of all these three, your primary alcohol or 1 degree alcohol will be the stronger acid, right? Then comes your secondary alcohol, then comes your tertiary alcohol, right? So your tertiary alcohols are weakest acid, then your primary alcohols are strongest acid, right? Tertiary alcohols are weakest acids because of plus I effect of three alkyl groups. Your OH bond is strongest, that will make the release of hydrogen more difficult in tertiary alcohols, right? I hope this is clear. Comparison of acidic strength of primary, secondary and tertiary, right? Now we have OH in. Now let's compare the acidity of alcohols and phenols, right? Acidity of alcohols and phenols. Since you have OH in phenols, right, and this OH bond, you have OH bond in phenols, right, you have OH bond in alcohols, right, both have OH bonds, but your phenols are more acidic than alcohols, right? So we say that phenols are more acidic, right? If you comparing with acidity, the phenols are more acidic, right? Acidity of phenols is greater than alcohols. Let's quickly look at the reason. We have done a different video lecture on this. There's a comparison of acidity of alcohols and phenols, but just a brief look here. Your alcohols will also release phenoxide ion and hydrogen ions. Since it can release hydrogen ions, so it is acidic. Now why it is more acidic compared to alcohols? They give alkoxide ion and your hydrogen ions, right? When we say that this is more acidic, right, that means you have more hydrogen ions. It can easily lose this hydrogen ion, right, and you have more hydrogen ions in solution. That is why this is more acidic. And when we say this is less acidic, that means it is difficult for this alcohol to lose this hydrogen. Even if it will lose hydrogen in solution, you have less hydrogen ions. When you have less hydrogen ions, that means it is less acidic. Why you have less hydrogen ions? We will be looking at that. There is something known as stability due to resonance or conjugation, right? Since you have benzene ring in this alkoxide, if you look, you have a benzene ring, right? and in this benzene ring one of the electron pair will get delocalized, right? It will start moving like this, right? This electron, one of the lone pair of electrons on oxygen atom will enter into this benzene ring, or what we say is it is in resonance with this benzene ring or gets conjugated with this benzene ring. So when this lone pair of electron will enter into this benzene ring, it will create point of high electron density at ortho and para site, right? And since this electron pair, one of the lone pair of electron is delocalized in benzene ring, it will, due to resonance, it will make this phenoxide ion more stable, right? Now since this phenoxide ion in solution is more stable, it will not immediately combine with this hydrogen atoms, right? Hydrogen ions. So you have more hydrogen ions in case of phenol. Why? Because the phenoxide ion, this phenoxide ion is more stable, right? It is more stable. That means in solution you have hydrogen ions and phenoxide ions, right? Because of its high stability, it will not immediately combine with this hydrogen ions to give you back phenol, right? Whereas if you look at this, if you look at alcohols, you have this alkoxide ion. Now this alkoxide ion has no stability due to resonance, right? There is no resonance in alkoxide. No resonance means it is less stable compared to phenoxide. Since it is less stable, so in solution it will immediately combine with hydrogen ions to give you back this alcohol, right? So this alkoxide ion cannot exist in solution because it is very less stable. So it will immediately combine with hydrogen ions to give you back ROH, alcohol. Or in other words, what we can say is it is difficult for these alcohol to exist as hydrogen ions, or it is difficult for this alcohol to release protons in solution. Why? Because of less stability of this alkoxide ion. This alkoxide ion will immediately combine with hydrogen ion to give you back ROH. Whereas if you look at this phenol is more acidic because the phenoxide ion formed by the ionization of phenol, right, is more stable due to resonance, right? Because one of the lone pair of electron enters into resonance or starts moving into this benzene ring, due to which it adds to the stability of this phenoxide ion. So this is more stable and it exists as, this phenol exists as phenoxide ion and hydrogen ions in solution. That is why it is more acidic. So phenols are more acidic than alcohols due to resonance stabilization of phenoxide ion, right? Simple. And why it enters into resonance? Because you have attached benzene ring in which one of the lone pair of electrons on oxygen atom is delocalized in the benzene ring or starts moving in the benzene ring. That makes it more stable, right? So we say, if you compare whatever we have done, that if you compare the acidity of alcohols, phenols and water, right, we say that water is more acidic than alcohols, right? And your alcohols and your phenols are more acidic than your alcohols, right? And if you compare the primary, secondary, tertiary, this is the acidic strength of primary, secondary and tertiary. Primary alcohols have maximum acidic character because you have only one alkyl group that shows inductive effect, plus I effect, whereas in tertiary you have three alkyl groups. So three alkyl groups showing inductive effect, releasing electron towards your OH bond, that will make your OH bond the strongest bond, hence release of hydrogen ion would be difficult, right? I hope this is clear. Thanks.